Welcome everyone. Today we are solving absolute value inequalities now. So instead of equations, instead of equal signs, we're going to have greater than signs or less than signs, or greater than or equal to or less than or equal to. So when we're doing this, we need to recall that the absolute value of x equals 3 means that the distance between x and 0 is 3. The inequality, the absolute value of x is less than 3, means that the distance between x and 0 is less than 3. And the absolute value of x is greater than 3, means that the distance between x and 0 is greater than 3. So these graphs are shown below. So the graph of the absolute value of x is less than 3 is shown here. Remember, the distance can be from 0 can be 3. So 1, 2, 3, and 1, 2, 3. So it could be 3 or negative 3. But the distance between those has to be less than 3, so it's going to the middle. Now we've seen this kind of inequality before, and that's our AND inequality. If we see less than, we know that it's an AND. Here it says the graph of absolute value of x is greater than 3. We know that we still have two solutions, 3 and negative 3. But this one, the distance between 0 and 3 has to be, the distance between x and 0 has to be greater than 3. So it could either go to the left or to the right. Greater than 3 or less than negative 3. So this is an OR inequality. So when we see the greater than sign, we know that we have an OR inequality. So if we solve these inequalities and graph our solution, well, we have the absolute value of x is greater than or equal to 6. Now, just like any other absolute value problem, this is going to give us two solutions. We'll have x is greater than or equal to 6, just like it says, or x, we have to now flip our sign, is less than or equal to negative 6. So our distance changes because of our absolute value. Because we switch from positive to negative, we have to flip our sign as well. So if we graph this, we have 6 and we have negative 6. The 6 has a closed circle, and that is pointing to the right. The negative 6 has a closed circle, and that is pointing to the left. So I saw that I had this greater than sign. I immediately knew that this was going to be an OR inequality. Here it says the absolute value of x is less than 0.5. I know that this one's going to be an AND inequality because we have a less than sign. So we will have x is less than or equal to 0.5. We also are going to have a negative, so x and negative 0.5 is our other solution. Then when we switch from positive to negative, we have to flip our sign. So x is greater than or equal to negative 0.5. So if we graph our solutions here, we have negative 0.5 and 0.5. These both have closed circles. The 0.5 is pointing to the left, and the negative 0.5 is pointing to the right. So just like we said, this is an AND inequality. Alright, here we need to solve these. Now, just like in our absolute value equations, we can think of this as like a shower. the absolute value means that inside our shower has to either something has to equal 8. There's two things that can equal 8. They could be 8 or negative 8, because our absolute value would give us 8 for both of those solutions. So if we create this problem, we're going to have x plus 3 is less than 8, just like we have before, and x plus 3. Now we're going to flip our sign, because we're flipping from a positive to a negative, and going x plus 3 is greater than negative 8. I see that this is a less than, so I know immediately it's going to be an and inequality. So I'm going to subtract 3. So we get x is less than 5. Subtract 3 over here. And x is greater than negative 11. So if we were to draw a graph, we would have 5 on the right and negative 11 on the left. 5 is an open circle pointing to the left. Negative 11 is an open circle pointing to the right. Here again, we know that something could either equal, or has to equal 7. So we know we can either have negative 7 or 7. So if we write these two inequalities, we'll have 10 minus x is greater than 7, or 10 minus x is less than negative 7. So right away I know this is a greater than, so this is going to be an or inequality. We're going to subtract 10. So we get negative x. Now remember to put that negative there because this whole thing is part of the x. 7 minus 10 gives me a negative 3. Now we're going to divide by negative 1 because that's what's attached to our x. So we get x. Now we divided by a negative number, so flip our sign. Negative 3 divided by negative 1 gives us a positive 3. Here, if we subtract by 10, we have negative x is less than negative 17. Again, divide by negative 1. So we get x. Now we divided by a negative number, so flip our sign. And we get positive 17. So if we were to graph this, 3 is our less number, so that's going to be on the left. 17 is greater, so that's going to be on the right. We have an open circle pointing to the left for 3, and an open circle pointing to the right for 17. Now we said this was going to be an or inequality, and our arrows are pointing the opposite directions, away from each other, so we know that this one was correct. Alright, here again we know that this is going to be either 17 or negative 17. So we have 2x minus 5 is greater than 17, and 2x minus 5, now we flip our sign, is less than negative 17. Now originally this is a greater than sign, so I know that this is going to be an or inequality. I'm going to add 5. So we get 2x is greater than 22. Here add 5. And we get 2x is less than negative 12. we're going to divide by 2. So we have x is greater than 11, and x is less than -6. So the lesser one of these is -6, that goes on the left. The greater one is 11, that goes on the right. 11 has an open circle pointing to the right. -6 has an open circle pointing to the left. Here we have a less than symbol, so we know it's going to be an and. We know our solution is either going to be 14 or -14. So if we draw write our inequalities, we'll have 8 minus 3x is less than 14, and 8 minus 3x is greater than -14. Here we're going to subtract 8 first. So we have -3x is greater or less than 14 minus 8, which is 6. Divide by -3. Now we divided by a negative number, so x is now greater than 6 divided by -3, which gives us a -2. Here again, subtract 8. And we have -3x is greater than -14 minus 8, which gives us a -22. Divide by -3. So x, now our sign flips. -22 divided by -3, that gives us about a 7.3. So graphing this, our negative number goes on the left, our positive number goes on the right. We have an open circle at -2 and an open circle at 7.3. And we have an and inequality, just like we said. Alright, these problems. We have our shower, and this whole problem is like our bathroom. We can't have anybody in our bathroom when we go to take a shower. So we're going to get rid of the thing that's in our bathroom, which is the 3. So I'm going to minus 3 from both sides. So 9 minus 3 gives us 6. We still have the less than sign. And now we have the absolute value of -4x minus 5. So we still have the absolute value, so we know our solutions could be 6 or -6. Our symbol is less than, so we know it's going to be and. So we have -4x minus 5 is less than 6. And -4x minus 5 is greater than -6. So if we add 5 here, we have -4x is less than 11. If we divide by a -4, our sign is going to flip. So we have x is now greater than a -2.75. Here we're adding 5 again. So we get -4x is greater than -1. divide by negative 4 and flip the sign. So we have x is now less than a positive 0.25. So we have an open circle at negative 2.75, and that is going to the right. We have an open circle at 0.25, and that is going to the left. So we have an and inequality, just like we said we were going to have. Here I think we're going to skip this problem. We're going to go on to the next page, where we have a couple more problems just like what we were going to have. Here we have our bathroom, and in that bathroom we have a negative 2. We need to get rid of this negative 2. It's touching our absolute value, so that means multiply. We have to divide to get rid of the negative 2. So we divided by a negative 2, so that means we have to flip our sign. Negative 8 divided by negative 2 gives us a positive 4. And we have the absolute value of 4x plus 3 is now greater than 4. So our two solutions are going to be 4 or negative 4. So we have 4x plus 3 is greater than 4, and 4x plus 3 is less than negative 4. So I'm going to subtract 3 from both sides here. And we get 4x is greater than 4 minus 3, which is 1. Divide by 4. We get x is greater than 0.25. Here subtract 3. We get 4x is less than a negative 7. Divide that by 4. And we get x is less than negative 1.75. So if we're going to graph this, our negative number goes on the left. It's negative 1.75. And our positive number, 0.25, goes on the right. 0.25 is an open circle, and that's pointing to the right. Negative 1.75 is an open circle, and that's pointing to the left. Alright, this problem here, we have to get rid of the stuff outside of our absolute value. So the first thing we're going to do is add 15. So we have 2 times the absolute value of 3w plus 8 is less than 10. Now we have to divide by 2 to get rid of the 2. We have the absolute value of 3w plus 8 is less than 5. So we know our solution could either be 5 or negative 5. So we have 3w plus 8 is less than 5, and 3w plus 8 is greater than negative 5. Subtract 8. We get 3w is less than negative 3. Divide by 3. And w is less than a negative 1. Here we have to subtract 8 again. And we get 3w is greater than a negative 13. Divide by 3. And w is greater than a negative 4.3. Now, if we're going to graph this, we have to see which one is less than. The one that is less is this negative 4.3. The one that is greater is the negative 1, because it's closer to 0. Negative 1 is an open circle pointing to the left. Negative 4.3 is an open circle pointing to the right. Alright, so we need to tell whether this statement is true or false. If it's false, give a counterexample. Now, a counterexample is a reason or another example as to why it's wrong. So the first one we have, it says, if A is a solution of the absolute value of x plus 3 is greater than 8, then A is also a solution of x plus 3 is greater than 8. So we need to figure out what the solutions of these problems are to figure out if this is true or not. So we know that this could be either 8 or negative 8. So we have x plus 3 is greater than 8, and x plus 3 is now less than negative 8. So subtract 3 from both sides. We get x is greater than 5, and x is less than negative 11. So if we graph this, we have negative 11, open circle pointing to the right, and 5, open circle pointing to the left. So we know that x can be anything less than negative 11 or greater than 5. Here, if we solve this, we just need to subtract 3. And we have x is greater than 5. If we were to graph that, we would just have a 5, and we have an open circle pointing to the right. Now, we know that in this first problem, x or a could be greater than 5 or less than negative 11. In this problem, we know that a can be greater than 5. So because these two have the same solution here, we know that this is true. A in both of these problems could be greater than 5. It doesn't have to be less than negative 11, but it could be greater than 5 in both the problems. Here, same thing, except this time we have a less than or equal to 8. So we have x plus 3 is less than or equal to 8. And x plus 3 is now greater than or equal to negative 8. So we're trying to prove if a is also a solution of x plus 3 is greater or equal to negative 8. So if we subtract 3 from both of these, we have x is less than or equal to 5. Subtract 3. We have x is greater than or equal to negative 11. So negative 11 goes down here. That's a closed circle, and that's pointing to the right. 5 goes here. That's also a closed circle. This time it's pointing to the left. Here, if we solve this problem, we know that x can be greater than or equal to negative 11. Now, so that's another closed circle, but this time it's just one line pointing to the right. Now we need to think about this, if this is true or false. We know in the first problem, x or a could be in between negative 11 and 5, so it could be like 2. Here we know that x can only be greater than or equal to negative 11. So it could be 6, but that's not true in our first problem because we know that it has to be between negative 11 and 5. So this problem is false because they're not true for each problem.